Hey guys, welcome to the first video of Dancing Code. In this video we are going to take a look at Python decorators. Let's get started. Let's say that we are writing a library code, and this library has a method called add, which simply takes x and y as a parameter and return x plus y. And let's say that somebody installed our library and started using it, like this. Add 30 plus 40, 60 plus 80, and etc. Let's see what we got. There we go. It is working the way we want it to, but let's say that something is not quite right here, and we want to do some inspection. Specifically, we want to measure how much time it is taking to execute this statement over here. What can we do? Well, the first thing that comes to my mind is import this time module, the time function from the time module, and call it like this. Call right before the execution, right after execution of the function that we want to measure, and then say time spent and subtract before from after. And let's see the result. There we go. It means that it took this much to execute statement over here. But what if we want to measure this one as well? Well, we could do this, right? Copy and paste before here, after, and that print statement here, and see the result. There we go. Everything is being measured, everything is good. However, we broke one fundamental programming principle here. We broke the dry principle. Don't repeat yourself. Right? We copy and pasted this much code here and here and broke the dry principle. What can we do to fix it? Well, another thing that comes to my mind is do everything inside the function, like this. Right? And then the print statement, assign the value here and return only after print statement, because the rest of the code wouldn't be reachable otherwise. And let's see the result. There we go. Oh, yeah. And then we could remove these statements here. Let's see the result. Well, everything is happening quite fast. That's why sometimes we are having 0 here. And that's it. Both of these functions are being measured in time. And we're happy because we didn't repeat any of the code. But let's say that we have another function that's called sub, which takes x and y as a parameter and returns x minus y. And our users started using our library, right? 50 minus 30, 20 minus 140, and let's see the result. As expected, add is measured, but sub is not. The reason is that we don't have this code inside the sub function. Let's fix that. X minus y here, and everything remains the same, and let's see the result. There we go. Okay, we have everything we want, but there is one more thing that's wrong here. We repeated our mistake and broke the dry principle once again. We repeated almost the same code here and here, right? And we want to fix it. Before we continue, let's remember something very fundamental about Python. Well, we all know that everything in Python are objects, even functions, which means that we can do something like this. Let's define a function called a, which simply prints I am a. And let's define another one called b, which takes a function as a parameter and just calls that function, right? This is allowed because everything in Python is object, and and objects can be passed over as a parameter to a function. Let's see if it would work. B, a. There we go. B took a as a parameter and called it inside itself. Another way that we could prove that everything is an object is access the properties of the function a, such as name or module, and etc. With that in mind, let's see something else. Let's also remember that Python is a runtime language, which means that everything happens from top to bottom. Well, it could mean that I could do something like this. In a for loop, define a function and call it after. And Python wouldn't complain because everything happens from top to bottom. And I'm just defining a function inside a for loop. That is allowed in Python. Well, with that in mind, let's fix our problem here. Okay, what if I created another function called timeIt and passed this add and sub as a parameter to this function? And this one also takes x and y, which add and sub take, right? And do this inside timeIt. Call this function here and pass x and y as its parameter and get these guys back to their previous state, to their original state, x minus y, and let's see the result. There you go. It is working, but there is no time. The reason is that we defined the function, but we haven't used it yet. Well, let's use it. The way you use it is like this. timeIt, and as function is our parameter, we remove the parentheses and replace them with commas. And let's see the result. There you go. We have the time for both adds. The reason we don't have for subs is that we haven't used them. We haven't used the timeIt function here and here. Well, everything is good and dandy. The functionality is there, but there's one thing wrong. We touched the user code. We made our users to change their code. Well, this is not what we want to do. We don't want to touch the user code. We want these user codes to remain intact. We just want to add a little functionality to our functions without touching the user code. Well, how can I do that? Well, we saw that we can define functions any way we want, even inside a for loop. Well, which means that I could define an inner function here, which takes the x and y and the outer function timeIt just takes the function, adds this functionality to that function, and return it. And the way you would use it is something like this. Add, and let's see the result. There we go. Add is measured, and if we do the same thing to sub, it will be measured as well. Well, what happened? Let's see. Well, timeIt took add as a function, added a little functionality here, and returned this function with extra functionality. And whatever it returned, we assigned it back to the add function. Now, this add function is the function that was returned from timeit, and that function takes x and y as a parameter. That's why we won't have to change the user code. And run the code again. There we go. We have the result we want. However, so far we have done pure Python. We didn't even mention Python decorators. Well, let's get into it. Python decorators are simple syntactic sugar which allows us to replace this single line here to this guy over here. The same thing with stop. And let's see the result. There we go. We have the same result. So let me repeat. Python decorators are a syntactic sugar which allows us to replace this guy here with this guy over here, right above the function definition, this small add, and the name of the function that we defined over here, the wrapper function. And we want to use it when we don't want to touch the user code, but add a little extra functionality to our existing functions. And that's it. Thanks for watching.